Okay, so we're moving into our next unit here. We're going to talk a lot about triangles for a while. Okay, so first of all, what is a right angle?
Exactly 90 degrees.
Okay, so it's exactly 90 degrees. Okay, what's an acute angle?
Less than 90.
Okay, it's less than 90, more than 0. We've talked about this before. So just a quick definition here. Okay, obtuse is what?
More than 90.
More than 90, yep, but less than 180. Okay, so what is an acute triangle?
Those are all less than 90.
Okay, it's a triangle where what? All the angles are less than 90. That's important, okay? So it can't be that two of them are and one's not. It has to be that all of the angles have to be less than 90. All of them. That's very important. Okay, next one. What's an obtuse triangle? A triangle where only one angle is greater than 90. Okay? So it's like this. Which one of those angles in there is the obtuse angle? Yeah, it's this one right here, right? There's the obtuse angle. Okay. What type of triangle is it whenever you have a triangle with two obtuse angles? What if you have two obtuse? What type of triangle is it with two obtuse angles?
There's a triangle like that?
Can you make a triangle with two obtuse angles? Because think about it, it's like this. Can you make a triangle from that?
No.
No, okay? I just want you to see that. No. If there's two obtuse angles, it's not a triangle. You could not make a triangle from it. Because if you think about it, what does the word triangle mean?
Three.
Okay, it means three angles, right? That's what the word literally means, is three angles. Okay. Next one is a right triangle. So what is a right triangle? Triangle where one angle is 90 degrees. Okay? What type of triangle is it if you have two right angles?
It's not possible.
Again, it's not possible, right? Because if you have two right angles, are those two sides, are they going to be able to meet up?
No.
Nope, unless you like bend it or something, but then it's not a triangle anymore, right? So you cannot have this one either. There can only be one 90-degree angle in a right triangle. Okay, next, scalene. So what's a scalene triangle? Okay, it's a triangle where none of the sides are the same length. So it's like this, where this is one length, this one is a different length, and this one's a different length. So none of the sides are the same length on a scalene. Okay, what's an isosceles triangle? Okay, a triangle where two sides are the same. So it's like this. This one and this one are the same length, but then this one's a different one. Okay, and this is dumb, but this is something I heard a long time ago, and it's always made sense to me. Okay, isosceles. I saw two leaves. I saw two leaves. I don't know. I think one of my students came up with that like a long time ago, but helps me to remember. I saw two leaves. All right, two of them are the same. Okay, and then what is equilateral? Okay, triangle where all the sides are the same length. All right, like this. All the sides are the same length. Make sure you're putting those marks on there because that's important. Those congruent marks on there. Okay, now here's another one you probably have never heard, but it's an equiangular. So what's an equiangular triangle?
All the measurements.
Okay, it's a triangle where all the angles are the same measurement. So this angle, and this angle are equal. Now we'll talk more about it tomorrow, but does anybody remember what the three angles of a triangle add up to? 180, yep. And so in an equiangular triangle, the angles are always the same. All three of them are the same measurement. So how big is each one of those going to be? Good. Good job. 60 degrees. In an equilateral triangle or equiangular triangle, where the angles are the same, they will always be 60. Okay, as long as we're dealing on a flat surface here. Now, one thing that needs to be said here is the equilateral and equiangular, these two go hand in hand. Okay? If it's equilateral, it's equiangular. If it's equiangular, it's equilateral. They're like peanut butter and jelly. All right, they just go together. It's not that they're the same thing, because they're describing two different things, but they are what we call being mutually inclusive. If there's one, then it's always the other. Okay, now, something I want to go back and talk about real quick. All right, these three classifications right here. Oh, whoops, no, hang on. I put that in the wrong, sorry. From acute, obtuse, and right. I'm sorry, I put that on the wrong one. Acute, obtuse, and right. On those three classifications, what's being described in these classifications right here? Okay, good. Angles is what's being described here. This is a classification by angles. It's important to see that. Acute, all of them are less than 90. Obtuse, one angle is bigger than 90. Right, one angle is 90 degrees. Okay? Then on these right here, what's being described on scalene, isosceles, and equilateral? Yep, the side lengths. Okay? And if you'll notice up there on our I will for today, you're going to classify triangles by angle measurements and by side length. And so those are our two there. And then obviously equiangular is another one of these that's a classification by angles. All right. Remote interior, angles on the opposite side from a triangle's exterior angle. So this is kind of a weird thing, but it's like this. We have a triangle where one of the sides extends out like this. Okay, so you got a triangle where one side keeps on going. This angle right here is the exterior angle that talks about. And then these two angles over here are the remote interior angles. Just because, and we'll be talking about triangles a lot, because we'll get into doing Pythagorean theorem stuff later. At the beginning of the next semester, we'll be talking about trig stuff. So we'll be all kinds of triangles we talk about. Okay, on the back, what does congruent mean? Same shape, same size, exactly the same. Okay? It means they're equal. Exactly the same. Now, we've got all these different methods of congruence proof. So the first one is SSS. What does SSS stand for? Side, side, side. Okay. So on all the rest of these, basically, we're going to draw two triangles. Look like jack-o'-lantern eyes.
I just said that.
Did you?
Yeah.
That's exactly what I was thinking. All right. Very appropriate for Halloween coming up in 2 or 3 weeks from now. Okay, so this side's going to be congruent to this side. All right? This side is congruent to this side. And then this side is congruent to this side. And we'll definitely be talking about this a whole lot more, like in 4 or 5 days, but I just want you to have this down where you can refer back to these. Okay? Next one is SAS. What is SAS? Okay, side angle side. So I'm going to have my jack-o'-lantern eyes here, basically. So it's like this. This side is congruent to this side. This angle is congruent to this angle. And then this side is congruent to this side. All right, next one is angle side, or what does ASA stand for? Sorry.
Equal side angle.
Angle side angle, okay? Yeah, that's terrible. Okay, so we're going to have angle congruent to this angle, this side congruent to this side, and then this angle congruent to this angle.
Go.
Okay, next one is AAS. What does that stand for? Angle side. Okay, so it's going to be like this. This angle is congruent to this angle. This angle is congruent to this angle. And then this side is congruent to this side. Okay, next one, SSA is what?
Same side angle.
Is side angle.
Or side angle.
Yeah, you got that same side on your mind. That's good. Okay, so it's like this. This side congruent to this side congruent to this angle congruent to this angle. Okay, then on the last one, AAA stands for angle. So this angle congruent to this angle congruent to this angle, and then this one congruent to this one. Okay, now before you switch over to the next page, I want to talk about something else real quick here. Okay, and if you'll notice the way I did this, the first 1, 2, 3, 4 there, it says method of congruence proof, and then the last two don't say that, and that's for a very specific reason, okay? So, again, we'll talk a lot more about this, but these first four, we're going to use these methods to prove that two triangles are congruent. So, this one works to prove congruence. Okay, this next one works to prove congruence. This third one, angle side angle, works to prove congruence. The angle side works to prove congruence. Okay, the side angle does not work. And the angle does not work.